Awesome. Can everyone see my screen?
Yeah, I can see your screen.
Awesome, thank you. So let's talk about the structure first. I will introduce the most important modules to you and then show you some basic examples for visualization in Python that will give you some ideas of what can be done with Python. First of all, the most important modules for visualization are NumPy, Pandas, Matplotlib, and Seaborn. So let's talk about NumPy first. NumPy is a library that is usually used for matrices and array calculations because it is relatively fast due to being computationally efficient. Another module we'll be using is Pandas. Pandas is convenient for all kinds of data frame operations and has very many options there for loading own data, configured data. There are various options. There's Matplotlib. Matplotlib is the most basic visualization library in Python, and it is very functional, but sometimes it just doesn't look that amazing. So there's this basic graph that you know that people will have in their research papers, and most of the time it's the one that they will obtain with Matplotlib. A more advanced one is Seaborn. Seaborn is a visualization library for statistical graphs and is based on Matplotlib, but has like more advanced types of graphs, and you can include more information in a visually more pleasing way. And with that, let's switch over to the examples. I have prepared a Jupyter notebook with examples that we will go over. So as you can see, at first, all the imports. So as I've mentioned, Pandas, NumPy, Seaborn, and Matplotlib are very important imports that we have to make for visualization, well, for different kinds. And we will be generating data ourselves, so we need the random module. And on top of that, we will be using an inbuilt dataset, the iris dataset, that we can import via this import with sklearn datasets. So once we have everything imported now, we can load the data. So as you can see, we've imported the load iris function with which we can import the data. And afterward, we take the information here that we've stored into iris and use pandas.dataframe. This stores the information into the data frame. So we take the data from iris and sort it into the columns based on the feature map. And with this command, we can display the first couple rows. So as you can see here, we have 4 columns of data with different numerical inputs. We can also get the names of the columns specifically by just calling our data frame. So we've named our data frame just df. And by calling this data frame.columns, we can get the names of the columns. And as you can see here, those are exactly the ones that are shown in the header of the data frame as well. Now, let's get started with the actual plotting. So what we want is the most basic type of plot to start with, which is the scatter plot. So for that, we can randomly extract 2 columns of our data frame up here. Let's pick the sepal length and width. So to do so, we create a new plot with a call to plt, which is the matplotlib, and call the subplots function. And then we can call certain operations on that. Scatter directly gives us a scatter plot, and then we pass over the values x and y. So from our column names, we can just randomly select 2 and then call our data frame where the name of the column is this name. And set the title with setTitle function. and labels with X label and Y label. Pyplot is very intuitive when it comes to naming conventions. But as you can see, the problem is those diagrams are like very basic to some degree when it comes to like details. And it seems like our data has multiple clusters. So let's inspect the data further. With our original data here, where we've loaded the iris data, we get multiple attributes that we can look at. One is the name of the targets. So we have 3 types of irises, and we have to figure out how to actually get those. So if we look into the target, which is another attribute, we can see that our different iris types are encoded into the numbers 0 through 2. As you can see, this is also a very small data set. This is because it's a toy data set to just demonstrate how visualization goes. So now let's say we want different colors for the different types of flowers that we have, or no, for iris. Depending on the color, we have a dictionary. So we know we have the class 0. Well, not the class, but we have the type 0, the type 1, and the type 2 in the database. And whenever we see an element of one of those groups, we want to have it colored in the same color, so we can create a dictionary with 3 entries. So if we get an entry that is 0, we want the color red. If it's 1, we want green, and if it's 2, we want blue. We can create a new subplot with the function we have used before, and then just loop over our data. So we look at our data frame, the column with the sepal lengths, and then we see how many rows we have by calling lengths. So then we loop over all the elements in the length of our data frame over those 2 attributes and set the color to be equal to the color of the target. So with iris to target, this was the attribute we've shown here. And we just iterate over all these elements. And if we run this code as expected, we get those 3 different kinds in their correct color. Now, sometimes those dots are like very big and might not be as detailed, so we might want to have other kinds of visualizing our data. One common example is to mark important parts in a graph with an X. If you look at the 2 areas here, there's only one difference, which is here this attribute which is called marker. Whereas the marker, there are many types of markers that you can choose. One of the common ones is X, and then you will have X's over the whole graph. If you want to know what other kinds are there, just go to the Matplotlib documentation and look for the marker feature, or generally just Google for the Matplotlib marker, which variants are there. So as you can see, with this attribute, we can easily change what we are looking at. So at this point, we already have 2 things we can change with our diagram, which is the color and the marker. So let's look at what data we have again. We have those 4 types. Now, sometimes we might want to show all 4 columns at the same time by just plotting all values in a line diagram. We can do this by just creating that ourselves. So similar to what we did here with the range. Another way to call this length is via 0 through the maximum number of rows we have. Oh, actually, columns. Let me see. Yeah, and we get our X data by just checking the dimensions here. And we already have df.columns as an attribute, so we can loop over each column. So for each column of data, we then look at our X data, which is given in that with the one array here that produces the X values we need, the column here, and we can label it by the column so we can distinguish between the different lines in our graph. So let's have a look at that. So as you can see, we have 4 graphs now of different colors, and all are drawn through. And that might be very helpful depending on what kind of data you have. In many cases, you also want graphs that are readable even if you can only print them in black and white. So in this case, you might want to try things like line style. Line style is another attribute of the Pyplot library. So let's have a look at it. As you can see, we get different kinds of graphs here based on what we're doing. So you can see one is simply bold line. The orange one has stripes. The green one is stripes and dots, and the red one is completely dotted. So how do we do this in our code? As you can see, the line styles okay, in this case, we just make a list of the line styles because it's easier for us to access. So we can just write it individually without having to write explicit calls for each and every single one. And if we look, the first line, just a minus would be the straight line. The 2 dashes, the same thing with like the orange one. So depending on which type of line style we pass over, we get different graphs, and depending on what kind we have, we might be able to use those things to make our visualization better in grayscale. Now let's look at a different example. Say, for example, we have random numbers in a list, and we want those to, well, we want to see how often they occur, so we want to create a histogram of those. In that case, we can just call an inbuilt function. So we have saved our random numbers in the variable random numbers using numpy. And when creating the new diagram, we can just call the function hist for the histogram, and it will create it automatically. And again, we can set things like type, title, X, and Y labels. So if we look here, we get a basic histogram. There are other libraries, like, for example, Seaborn or CV2, depending on the context of what we're working in, with which we can make more advanced histograms. But this is like the basic histogram that we can get. Oftentimes, we don't want to show only histograms only, but for example, heat maps. Let's create some random data for the heat map. So heat maps are more advanced plots, and those are within the Seaborn library. So Seaborn generally is set up the way that the graphs look nicer. So the call is pretty easy. We just call Seaborn, the function heat map, and pass our data. When we do that, we get the heat map with different values. As you can see, we've got the numbers of like what was created here, which in of itself can be a little bit annoying if we don't need that information. So Seaborn has a feature that allows us to get rid of those. Namely, we can just take the heat map call and add 2 more parameters that we pass over. And that is, we take X tick labels and Y tick labels. and set both of those to false. By default, both of them would be set to true. So let's look at how this looks. Oh, also X label and Y label can be accessed via plot. So, and this is the point where you can see that Seaborn is based on the PyPlot variant, because you can easily just combine those. Also up here with the plt.show, which is a PyPlot function. So by adding those labels instead of the numbers at the sides, we can improve our data a lot. Now, another thing is that sometimes we might want to portray the data with a certain color map or a certain group of colors. And for that, there's another feature as well, which is CMap. There's a whole list of CMaps. So if we look here, one option would be with green and blue to get this. In fact, if we put an invalid value here, we would just get a list of proposed values, like which could be used or which we might want to use. Now for heat maps, one important thing is that you want to decide what combinations are best to some degree if you don't have completely randomized data. And for that, you will want to know the exact numerical value. For example, if you assume the dark values are best, is this value better? Is this value better? Or are both the same? And for that, it is important to have annotations within the graph. We can add those with the annotation feature here, and then just show them. So as you can see, Seaborn has many parameters that we can set that help us improve our graph to what we need. Because now we can distinguish really easily that this field would be better under the assumption that the highest value is best. As I've mentioned before, Seaborn is mainly for statistical data. So sometimes you want to see like what the mean value is and what the range is that it varies from. And let's import a new data set for it. And for this data set, it's for tips, we will plot here. The data itself is stored in a way that like the names are the variables within the data set. So we will plot the days on the x-axis, y the total bill, and use the tips as the data that we put there. So this is for a box plot, so the one where you can see the difference. And this can be really helpful to see like how things are alternating and how it changes over time. Sometimes you might want to portray multiple things combined together, or also change the color templates. So we can do so with the U data and the palette. So the palette is just our color set again. So if we look here, now we can portray pretty much 3 dimensions of data. We can say which day, what the total bill is, and if the customer is a smoker or not, and we can get an overview of the data really easily. So this is the basic information that I want to show you, and now I will open it up to questions. I will actually stop the recording so you feel more confident doing so.